Hello viewers, we carry on with some applications of ordinary differential equations, which is a part of the mathematics course in semester 2, and in all lectures I am indicating a course name or number. Basic science course, aim is for mathematics, and 2 is indicative of semester 2. Today in this lecture, we will concentrate on geometrical applications of differential equations. So I have written subtangents, subnormals, of course after tangents and normals, because there are certain concepts to be explained. Now let's see what those concepts are. We will first get to, we'll do all this together, and let's see how to frame up this lecture in a logical sequence. First of all, I would like to give you the definition, for those of you who don't know, what is a subtangent, what is a subnormal, what is a tangent, what is a normal, and you will see that some of these were known to you, some of these are absolutely new concepts. First, we need to draw a diagram. So while we are rubbing on the board, I'll tell you what I'll do. We'll draw a diagram, define what is the difference between a tangent as far as this calculus is concerned and equation of a tangent. Now let's see. I'll draw a diagram. Step 1, draw a vertical line, call it the y-axis. Draw a horizontal line and call this the x-axis. Draw a curve, draw a tangent. Well, I've drawn a chord, not a tangent. Let's try it once again. A little off. That's perfectly all right, no problem. Let's see if we do it like this. First, draw a straight line and draw the curve after that. This is, I think, better. The idea is better. That means there is a curve, let's call it C, and there is a point P, we call it xy, x, y. This point is the point of tangency or the point of contact of the tangent to the curve C at the point P. Let's say that this tangent intersects the x-axis at a point T. So this point is T. Then we draw a normal. We draw a normal to the curve at the point of contact. And this normal we call the point where it intersects the x-axis N. From P, we drop a perpendicular upon the x-axis. We could do this like this. Let's see if we can get a better idea. Straight lines should look like straight lines. So when they don't, I feel a little upset. So what we do is we put this up here and get something that is a much better straight line, I think. Yes. So let's see. Standard terminology. P, we can call this Q as the foot of the perpendicular. We call it F also, because F would be standing for the foot of the perpendicular from the point P, xy, onto the x-axis. This angle, which the geometrical tangent makes with the horizontal axis, is called psi. Angle made by the tangent to C at P, and this is called PSI, psi. PSI. Those of you who understand Hindi, it's very simple. If you write it in Hindi, this is perhaps how it looks like, psi. The other fellow is phi. It's written like this. That's something else. In polar coordinates, this has a different meaning, but psi in differential calculus, whether in Cartesian coordinates or polar coordinates, we write it for the angle that the tangent makes with the positive side of the x-axis. So in Cartesian coordinates, one can write easily dy dx is tan of psi. And this is a point by point phenomenon, because as we go up and down the curve, the position of P changes, the position of the tangent changes, the value of psi changes, and obviously dy dx changes. That's nothing great. Now, Pt, Pn, Pq, psi. If one sees this is 90 minus psi, so this fellow here is also psi. That's not a big deal, because the normal makes 90 degrees with the tangent. So if this is psi, this small fellow is 90 minus psi, which we'll write here. Put two lines and write 90 minus, this angle here is 90 minus psi. So the remaining angle is psi. A careful study states the following. Let's see. Before we put any mathematical formula on the board, we would like to define four terms. One is tangent. Second is normal. Third is subtangent. And fourth is subnormal. So we put 1, 2, 3, and 4. Now tangent, anybody will say, sir, we know the meaning of tangent, please don't waste time. No. Here, it is not this line that extends to infinity on both sides that we are talking about. We are talking about the portion of that line that is contained between P and T. So the length of this, PT, is the tangent. This is perhaps new to some people, especially students. P to T, that means from the point of contact to the point where the tangent meets the x-axis, is called the tangent. So tangent is P, T. Similarly, normal is, of course, a line that extends to infinity on both sides, but that part of the normal which is contained between the point of contact and the point at which it meets the x-axis is called the normal. So here in this diagram it is Pn. These two are newer terms. Subtangent now is the distance between the point where the tangent intersects the x-axis and to the foot of the perpendicular. So we write this as 3, subtangent. So here subtangent is QT. 3. Fourth is subnormal, and that is nothing but where does the normal intersect the x-axis at N. From there, what is the distance to the foot of the perpendicular? So Qn. These are the terms defined, the geometrical definitions of the terms. Now can we put some mathematical values? Let's see. This is y, and this is what we need as a subtangent. So if we are talking of subtangent, qt, pq over qt, let's write pq over qt is tan psi. All of us know that PQ is nothing but y. So this implies y over qt. What is tan c? Dy dx, y sub 1. In other words, that is dy dx. In other words, my friend qt is y over y1. So we capture that result. Qt is y over y1. Y sub 1, that is the first derivative of y with respect to x. There we are. Second is subnormal. Subnormal is Qn. One can see that Qn over y is tan psi. So Qn is tan psi into y, that means y into y1. Once again, one can see, okay, let me write a bit. Let's rub out this part. Some people may find it a bit uncomfortable if I keep on working mentally and put down the results. See, we need Qn over PQ is nothing but tan of angle NPQ, or Qn, PQ is y, y is tan psi, tan of psi, and that is nothing but y sub 1. So our subnormal is y into y1, y sub 1. So one can write that. We can say subtangent is y over y1, and subnormal is Qn, and Qn is y into y1. We can rub out the board after this and tackle a few problems. Let's see. We fish out a few problems. I have a list of problems, so we can fish out a problem. That's not a problem. It's not an issue. It's all right. Now, let me rub out this board and try to do a problem. We have to box the two major relationships that we got. So we got so far Cartesian subtangent, Cartesian subtangent is y over y sub 1, and B, the Cartesian subnormal y into y sub 1. These are two important relationships that we must remember. It's not a problem. One is y over y sub 1, the other is y into y sub 1. I drew the diagram extensively, because if you forget the expressions, you can always draw a rough diagram and derive. It's not a problem. We've done that in high school, in our earlier days, young days. Now let's see if we can fish out a problem and solve it. We will do that.